Okay, this is going to be the third video in the series on how to change a rational function into a geometric power series. And if you haven't done it yet, I would definitely watch the first two videos. As in the first two videos, I would suggest beginning with just the definition of a geometric series. And you should remember this from earlier in the course, that the summation of a times some common ratio to the n is a geometric series. The sum of a geometric series is given by this formula, a divided by 1 minus r. And also remember that the series converges when the common ratio, the absolute value of the common ratio, is less than 1. And just like in the first two videos, what we'll do is take whatever function we're given and transform it into this form, this a divided by 1 minus r form. Once we've got it in this form, then we can come up with the summation notation and then finally use that to get the interval of convergence. So let's take a look at an example and see what it looks like. Now, the difference between this and the first two videos, in the first two videos, in the numerator, it always just had a number, maybe like a 2 or a 3 or a 1. Well, in this video, you might run across problems that have an x in the numerator, or an x squared or an x cubed, whatever. And it changes the way you go about it just a little bit, but the basic process is going to be just like we did in the first two, is to take this red rational function and try to transform it into this form, a divided by 1 minus r. So we want to try to wind up with a 1 here, a negative here, and then we'll just take whatever we can get for a and r. Now, again, just like in that first video, the first thing I would suggest you do is just take this original function and write it down. So we'll go ahead and put that right here. So I'm going to have x squared. And let's see here. I think I'll erase that, and I'm going to put this in black just to be consistent here. So let's make this be x squared divided by... and I've got 1 plus 3x. Again, you always, as you work with this, you always want to be looking at this form over here. Now, the first thing I need is this, is in the numerator, I don't need any x's, I just need to have a number. So my first step here is going to be to take this x squared and factor it out. I'll make it be x squared. Then I'll have in parentheses here, this is going to be a 1. And't have 1 plus 3x, whole thing in parentheses. So the first step is trying to get it into this form. You don't need any x's in the numerator, so if you have an x or an x squared, factor it out and get to this. Now, just like we've done in those previous videos, I'll write this as x squared, and then in parentheses, and again, I've got a 1 in the numerator, and I'm going to do the same thing we've done before. I've got a 1 plus, but what I need is a 1 minus. So I've got to change this plus to a minus, and the way you do that is to make it be minus a minus 3x. Now it's in the right form. Then I'll come over and close the parentheses. So now I've got it in the form that I needed, with the exception of the fact that I've got this x squared out here. But what I need a 1, there's a 1. I need a minus, there's a minus. And at this point, I've got it just like we did in those previous videos down to this. So this is going to be my a, and this is going to be the common ratio r. So now the next thing we did, we always wrote it in summation notation. So I'll do the same thing right here. I'm going to start with just write the rule out, the summation as n equals 0 to infinity of a sub 0 times r raised to the n power. But the only difference on this problem is I need to put this in parentheses because what this summation is, that's the part inside the parentheses. But remember, you've still got this x squared on the outside. Matter of fact, I think I'll put that in red just so it kind of stands out. So I've got an x squared times this summation. So now I'll go ahead and plug in the things that we've got. So first of all, here's the x squared on the outside. And then it's times the summation as n equals 0 to infinity. And in place of a0 is a 1. Then I've got r, but r is minus 3x raised to the n power. So what that gives me is this is a, and this is r. So you've got it down to there. Well, now it's just a matter of dressing things up a little bit, so let's follow the same things that we've done before. And again, I'm going to keep that x squared in red, just so otherwise it's easy to forget it. So I've got an x squared, and I'll make this be the summation as n goes from 0 to infinity. And I'm going to use the same trick that we've done before. Anytime you've got a negative, you can bring that negative out as a -1. So just like in those previous videos, I'm going to go ahead and bring that out as a -1 to the n, and then that's going to be times 3x raised to the n power. And we'll just keep going on this thing. I'll make this be, here's the x squared, and then I've got the summation as n goes from 0 to infinity. Here is the -1 to the n. And I think I'll also do this, is I'll change this into 3 to the n times x to the n. So this would be 3 to the n times x to the n. Now, here's where you finally start bringing this x squared back into it. What you can do is take the x squared and bring it back inside the summation. So you can bring it from here and bring it over here and put it right here. And so now it's not here anymore. So bring it back inside the summation. And what that allows you to do is this. That's going to give you n is equal to 0 to infinity. And here's the -1 to the n. Then you've got 3 to the n. Now here you can add the exponents. So n plus 2, this would be x to the n plus 2. And finally, you have got a power series. So, took a little work to get there, but that's what it's going to look like. Now, to find the interval of convergence, just like in those previous videos, for a geometric series, it converges wherever the common ratio is less than 1. Now, as far as what to use for r, don't use anything over here. Go back to the original problem, and r is right there, -3x, whatever's inside the parentheses. So this is going to become -3x. Absolute value of that is less than 1. Now again, when you take the absolute value, that negative will disappear, and you can factor that 3 out. So that's going to be 3 times the absolute value of x is less than 1. And we'll move that over here. Divide both sides by 3, and you'd get the absolute value of x is less than 1/3. So if the absolute value is less than 1/3, that means that x itself has to be less than, not like less than or equal to, but just less than a positive 1/3 and greater than a negative 1/3. And what this does, this gives you the interval of convergence. And again, if you'd like to, you can write it in open interval notation. So this is going to be -1/3 to a positive 1/3. You can write it like that if you like. And then also the radius of convergence is whatever the absolute value is. So in this case, the radius of convergence goes from 0 out to 1/3 or from 0 out to a negative 1/3. So the radius is going to be that right there. So there's the first example. And the whole trick to this is just this. If you have an x in the numerator, go ahead and, I think we'll do it in red here, go ahead and factor it out. And just keep it out here all by itself. Carry it all the way through the problem, and then right at the end of the problem, bring it back inside the summation, and if you can, combine it with whatever other x's are in there, and you'll get this, and that'll give you the series. So there's the first example. And we'll try one more just to give you a second look at this. Okay, now what this one's got, it's got 2x times this right here. And again, same thing, we've got an x in the numerator, so we'll use the same little trick to factor it out of the numerator. So I'm going to make this be x. My first step is to go ahead and factor out that x, and that's going to give me this. Now, if you wanted to, you could bring the 2 out. It's your choice. You can bring the 2 out, or you can leave the 2 in, and either way you'll get the same answer, but I think I'll go ahead and just leave it in here. So here's going to be a 2. I'm also going to use that same little trick before. Over here, eventually I'm going to need a number minus something x. So since this has got the number last and the x second, and they're plus, I'm just going to switch those and put the 9 first and put the x squared second. So that gets it in the form where it's beginning to look like this over here. Now at this point, just concentrate on what's inside the parentheses. So that's going to give me an x times n. I'll put a bar across here. Here's the 2. And I've got the same problem. I need a number here, and I've got a number. I need a minus, but I've got a plus, so I'm going to use that same trick that we've used on the previous problems. I'm going to change it to the negative of a negative. And that will give me, now it's in this form. I need a number minus something, I've got a number minus something. Now again, bad luck on this problem. I need a 1 here, but I've got a 9. So I've got to change that 9 into a 1. And the way you do it is to divide by 9, but whatever you do to one term, you've got to do to all the terms. So I'm going to divide by 9. I'm going to divide the numerator by 9, and I'm going to divide this by 9. You have to divide all the terms by 9. So what that's going to give you, now I've got an x in parentheses. Here's the bar again. And in the numerator, I've got 2/9. This turned into a 1, which is what I wanted. I've got a minus, then parentheses, and I've got negative x squared divided by 9. Parentheses here, extend the bar, and bring the parentheses down like this. Now at this point, got it in the right form. I needed a 1, I've got a 1. I need a negative, I've got a negative. And I'll take whatever I've got right here. It's just whatever is in the numerator is my a term, and whatever's in the parentheses is my common ratio. So now, it's a matter of writing it again. Again, don't forget about this x, because now we just change this into the summation form. And again, I think I'll start by just writing this x in red on the outside so that I don't forget about it. And then I always like to start by just writing the definition. So this is going to be times, in parentheses here, the summation as n goes from 0 to infinity, sum a times common ratio raised to the n power. But I still have that x on the outside. So again, I'll always, just so I don't forget it, I'll leave that x in red and make this be the summation as n goes from 0 to infinity. And in place of a, I'll put 2/9. So that's going to be 2/9. The common ratio is negative x squared divided by 9 raised to the n power. And just to remind myself, I'll put a little arrow here. That is a, and this is common ratio r. And now it's just a matter of cleaning everything up. So we'll make this be, again, we'll put that red x out here in front. So there's the red x. Then I've got the summation. So n goes from 0 to infinity. And again, here's a negative raised to the n power. So using that same trick, go ahead and factor out a -1. So I'll have a -1 to the n power. Then here's the 2/9. Then, and I think I'll write this as this. Now I'm going to have an x squared. And let's go ahead and do it this way. We'll make it be an x. Now at this point, I'm going to distribute that, or raise both of them to the power. So I'll have x squared to the n. You multiply the exponents, this will turn into x to the 2n. Then in the denominator, 9 raised to the n, that'll become 9 to the n. So all you did there is just raise both things in there to that power. Well, now that allows you to do this. Here is, again, that x is still on the outside. So I've got the summation as n goes from 0 to infinity. There's my -1 to the n. And I think I'll do this little trick next, is think of this as being 9 to the first power. So in the denominator, you've got 9 to the n times 9 to the 1. You can add the exponents, and that's going to give you, now first of all, I have this 2 in the numerator, but in the denominator, 9 to the n times 9 to the 1 gives you 9 to the n plus 1. So you can change that into that. And then finally, you've got this x to the 2n right here. Now you're almost done. Your last step is to do just what we did in the last thing, is now you can bring this x back inside the summation. So I'll bring it back inside the summation. That's going to become x to the first power right there, and I'll move it out of here. And then finally, the last step is to, now I can write it as a single summation. So the summation is n goes from 0 to infinity of -1 to the n power, 2 divided by 9 to the n plus 1. and go ahead and add these two exponents together. So x raised to the 2n plus 1, and finally you're done. So you got to take a while to get there, but that's going to be the geometric power series representation of this original thing. Now the next thing you need is interval convergence. So just like before, remember you always start with the absolute value of the common ratio has to be less than 1 for a geometric series. And again, to find r, rather than looking over here where you've changed everything around, go right back here to that initial step. R is equal to minus x squared divided by 9. So that's going to be minus x squared divided by 9. The absolute value of that is less than 1. And using the same argument, when you take the absolute value, that negative is going to disappear, and you can factor a 9 out. So this will become 1/9 times the absolute value of x squared is less than 1. Then we'll move it up to here. Next step, multiply both sides by 9. So you'd have the absolute value of x squared is less than 9. Now again, if the absolute value of x squared is less than 9, then square root of both those would give you the absolute value of x has to be less than, square root of 9 is 3. And then if you've got an absolute value less than 3, that means that x itself has to be less than a positive 3 or greater than a negative 3. And that's going to be the interval of convergence. And again, if you want to, you can write it in interval notation as minus 3 and 3. So you could write it like that. And then the radius of convergence is the distance. So the radius of convergence would be the distance from the center to the endpoints. So in this case, the radius of convergence would be 3. So anyway, it's kind of like the other one, but the trick on these, again, is to, if you've got an x in the numerator, go ahead and factor that x out. And it's your choice. If you want to bring the 2 out, you could put a 2 here, here, here. You could carry that 2 all the way through the problem and then bring it back in just like you brought this x back in. So it's your choice whether you bring the 2, but definitely go ahead and bring the x out because then you can get it in the right form. So anyway, follow those steps, and there's a third example of how to convert a rational function into a geometric power series. And we'll do one more in the next video. So far, the first 3 videos, all the series were centered at 0. In the last video, we'll do a couple of examples where the power series is centered somewhere other than 0.